Hello guys, this is a little infomercial for you on Tuesday the 20th. So yesterday you were given the existence theorem handout, unless you were distance learning, in which case you either printed it off or doing it on a blank sheet of paper. There was a video, you were supposed to follow through with it. Now some of these videos are from last year, so keep in mind I might reference things that aren't the case now. So just make sure you're watching these slides really carefully. So you were to start with the video, and then today we're going to do warm-ups. We're on number 17, I think it says 16, but we did 16 already. So we're going to do 17 to 21, and we'll change this guy down here to 22. Whoopsie daisy, where did that go? Sorry guys. Let me hop on here for just 1 second. I'm going to update right here. So we're going to make that the 22nd. These warm-ups, by the way, are due. They're just not going to be due until we're completely done with all of them. But as I've said, put them in the back of your binder. DL, put them in a notebook all in the same spot. So your task is just going to be the warm-ups, which you've just logged into, and then the handout. Now that's number 22 and 24 of the next set that's going to be collected, which is on Monday the 26th is when I'll do my next collection. So keep that in mind. Also, there's extra credit running here. So I've decided to keep the extra credit all in one Google form because I'm having a hard time keeping track of it. So AP or College Board makes a set of live YouTube videos. They're pretty good. We used them last year quite a bit during distance learning. I can't say I loved them, but I loved parts of them. And so I've made them extra credit this year because the test is sneaking up kind of fast on us. So in 6th hour, you can fast forward this because I gave you this speech yesterday, so you can just fast forward to the warm-ups. But you'll see that tonight, I'm doing these on Monday, but tonight in 3 hours at 6 o'clock, we will be having the first of the AB live sessions. It's on understanding derivatives and understanding of the chain rule. So what you're to do to get some extra credit is if you click on this show more, you'll see the handouts. You can print that off or you can just follow along in the notebook. You can do one of them, two of them, or none of them. All right? It just depends on what, if you're like, I don't think I need any of that and I already have an A and don't think I'll be on a grade bubble, then don't do them. If you're, and conversely, if you have an A, like a 99%, but you're like, I never quite got those Riemann sums or whatever, then you would do, where's a Riemann sum? I don't know. Somewhere on here. So anyway, they're going to run along the left side here, but I will keep a link running. On your master schedule, before we get started, I just have one turn-in kind of right in the middle where it says extra credit Dropbox. So I'll accept stuff anytime between today and the morning of May 4th, which is when you take your exam. So anything you do for extra credit, we're just going to have this one Dropbox that we're going to put it in, and I'll tally all the points at the end of these last 2 weeks because doing it individually has been really hard for me to keep track of. All right, if you have any questions, just email me or remind me. I'm always checking stuff this time of year. So let's hop on and do those reviews. 17 to 7 to 21. 16 is where we wrapped up last time. If you're missing any, you should go back because these are going to be a hefty chunk of points at some time once we're done with them. So we are on number, 17. Got to scroll to it. This was for my last chapter 7. Which one is a solution? So remember, to be a solution, it has to work. These are a little frustrating because you need to figure out which one will cause you to get a 0 out, which means it's kind of working from the answers backwards. So the first thing we're going to do is take y prime, the derivative of e to the u is e to the u du, plus 7 and minus 0. We'll do a y double, constant stay put, e to the u du. And then again, that 7's going to go to 0. So my second derivative is this. Now I need to take my second derivative, my first derivative, and my original, and go see if they spit out a 0 under the operations shown here. Y double prime 4e to the twice x minus twice y prime 2e to the 2x plus 7. Plus 7, do you equal 0? And I would do the arithmetic as fast as you can. It looks like the 4e to the 2x will cancel off. but the rest of it won't. So nope on that one. Now let's see for y, double prime minus twice. Let's see if that equals 0. By the way, if you remember when we did these in Chapter 7, I said for these multiple choice, it's usually a first or the second, or it's a time sucker-upper. So you'll notice on this one, I get the minus 4e to the 2x minus 14, and then plus 14. So B is my winner for the solution. Number 18, the derivative of arctan X. It's the prettier one. They all have U prime on the top. Arctan is pretty because it has the plus and no root. In this scenario, it's the easiest function you could have. The derivative of x is 1. And when I square it, I get x squared. I'm supposed to do this at 1. So this is a memory, if you can remember. So this is a good time to remember the derivative of arc sine u is the uglier one for 2 reasons. It has the root and it has the uglier operator. You really just do need to memorize those. If I were to plug 0 into this, I'd get 8 times 1/2 cubed, which is 1 minus 1. I get the 0 over 0. You have 2 options. You can recognize this as the formal definition of the derivative, where it's f of x plus h minus f of x all over h, the limit as h approaches 0. And if you recognize that, you just really need to figure out what's the function. 8, and then it'd be x plus h, right? So it'd be 8x cubed is my function. How do I know that? Well, if you take a look at this, f of x plus h minus f of x. You may say, well, how is there a 1 there? Well, remember, this is 8x cubed's derivative at x equals a half. And if I put a half in here and cube it, 8 times 8, which is 1. So this is f of x. So at x equals a half. So this is 8x cubed derivative at x equals 1/2, which would be 24x squared. 24 times a half squared is 6. Now, if you don't like that formal definition of the derivative, you could L'Hopital it. Okay? When you do L'Hopital's rule, it'd be the derivative with respect to h of 8 times 1/2 plus h quantity cubed minus 1 over h. Okay, and when I do its derivative, I'd have 24 1/2 plus h squared, gone, goes to 1. And I am doing this, I have to sneeze. Excuse me. Got it. And I'm doing this now when I plug h equaling 0. So when h equals 0, I get 24 times a half squared. So either way, I think the intent is the formal definition of the derivative, our second to the last one. If the derivative, the first derivative with respect to x is sine y plus 1, the question is, what's the second derivative? Which would be the derivative with respect to x of the first derivative. So our second derivative would be the derivative of sine, which is cosine of y times the derivative of the guts, plus the derivative of 1, or any constant, is 0. I'm supposed to do this at x equals 0, so I need to find the second derivative when x is 0, or at the point 0 comma pi thirds. This has become a function of y. So I would do cosine of y pi thirds times dy dx. Sine y If this was an FRQ, you would quit because that's all numerical and it's exact, but you don't see that here. So they make sure you can simplify in the multiple choice. So let's go back to our good friend, the unit circle. We've got pi sixths and we've got pi thirds. It's always a 1/2 in this far right corner. It gets paired with root 3/2. Pi thirds reverses. So let's see, cosine of pi over 3 is its x value. Pre-calc here. Sine of pi over 3 is root 3/2 plus 1. Bummer, they simplified it even more. Well, then I need to simplify it even more. Again, I'm done with the calculus. I have root 3 over 4 upon distribution plus 1/2, but I need a common denominator. So 2/4, which gives me a 4 in the denominator and a root 3 plus 2 in the numerator. Oh, there it is. I skipped over it. It's letter A. So this is implicit differentiation. Watch that. Again, the derivative of sine of x is cosine x times the derivative of the guts. So that's when we say it's just cosine x. But when it's y, it's cosine y times dy dx or y prime. Last step, number 21. The table of values gives the values for g and g prime. So here's my x value, here's my y value there, here's my slope there. H is a composite function. It's g of another function. We are to find the slope of the tangent line to h. We need to derive it. We need to do h prime. This is not a product of functions. It's not a quotient of functions. It's the chain rule. The derivative of a function inside of a function. So we'll repeat on our chain rule. For example, it's much easier when we can see, since we were on sine on the last one, there's a function inside a function. We do the outer function's derivative, leaving the guts intact. So the derivative of sine is cosine. We leave the guts intact. Times the derivative of the guts. So this one would be times 4. So now let's go do that exact same process. We've got g, which is an outer function. It would have been sine in this scenario. We'll take its derivative. But when we're done, we're going to multiply it by the derivative of the guts, which would be 3x squared minus 1. We're to do that when x is equal to -1. When x is equal to -1, I'll have g prime of -1 cubed minus -1 times 3 times -1 squared minus 1. I'm going to have g prime of 0 times 2. So I just need to go figure out what g prime of 0 is. Looks like it's a -2. Here's 0 and here's g of 0 and there's g prime of 0. So that's a -2 times 2, which is a -4. Very typical way for AP to test the chain rule. When you don't know what, sometimes they'll even do it, watch this, they'll go like f of x squared plus 1 dx on an integral. And you'll be like, oh, that's a function in a function. But I don't know what the outside function is, but this is a use of problem where use the inside function. The derivative would be twice x dx. So usually what you'd see is like an x out here. I'll throw that on there. Sorry. When I make these up on the fly, sometimes I miss some details. So my 1/2 du will equal the rest of the integrand. So if I wrote this all in terms of u, I had the indefinite integral. I let u be the inside function. X dx was 1/2 du. And sometimes this will even be like an f prime right here. That'll be like an f prime right here. so that when you calculate, and maybe this was a definite interval, I'm just doing for shits and giggles here, but we've got to learn as much as we can here in these last 2 weeks. Then we do 1/2 of, oh, change your limits. This is good review. I just threw this one on here off the top of my head, but I love this problem I just made up. We'd go from 1 when x is 0. 5 squared plus 1 is 26. So we'd have 1/2. The antiderivative of f prime is just f. 1 to 26. And you might say, well, how do I get that? Usually you read f of 26 off a table and f of 1 off a table. So we would do 1/2 of, and again, this has nothing to do with this problem, but College Board likes to test these rules with generic functions, which for some people can be easier because you're like, well, I don't even need to know what g is. I don't have to know. I just have to know that its derivative is g prime, or you know what I mean? But and then this will go from 1 to 26. Oh, sorry. Talking too much. So that'd be 1/2 of f of 26 minus f of u. 1. Now, where would you find those? Usually off a table, maybe sometimes off a graph. But keep in mind, look at the process. It's a unique or clever way of testing u sub. Here's u, the rest of the integrand, all right? Add a fraction correction, changed my limits. The antiderivative of anything's derivative is itself. All right, we're done. Your task is to finish the existence theorem.